A pilot flies for a total of 4 hours with an average velocity of 135 kilometers per hour, going north 32 degrees east. In the first part of the trip, the pilot flies for 1.5 hours with a velocity of 150 kilometers per hour, going east 12 degrees north. She then flies directly to her destination. Determine the displacement of the second part of the flight. So, what we should do right away is label everything we have to help us out with the equation. So, for our total time, it is 4 hours. And then our average velocity for the entire flight is 135 kilometers per hour. Then we have our angle of 32. And now we can see from both these materials we can change them into displacement for our total displacement. So we will do that. So we will take the 135 kilometers per hour and we can times that by 4 hours. And then this here equals 540 kilometers per hour, or kilometers, sorry. And then we need to keep our angle that we still have here. Now I'll draw this out real quick to show what it looks like. So we'll keep a triangle here. And now our angle is going up north and then it's going east. So it's going up and then over. So that's why our triangle looks like this. And then this will be our 32 degrees right there. Okay, and now we have a couple numbers for the first part of the flight. So part 1, we have the time, which is 1.5 hours given to us right here. And then we also have the velocity of the first part, which is 150 kilometers per hour. And then again, we have our angle. Our angle is going east 12 degrees north. Now again, from these we can figure out our displacement for the first part. So we will want that. So we will take the 150 kilometers per hour. We will times that by 1.5 hours to get rid of the hours, so leave it just in kilometers. And this equals to 225 kilometers. And then again, we need to keep the angle from our velocity. Okay, and then I'll draw this out again. And now since this one is going east and then north, it's a little different than this one is. So we will have our dotted line in a different spot than the other one because our angle this time is going east and then going up north. So it needs to be on the other side. It'll be 12 degrees. And then the displacement is 225 kilometers. Okay, and then for part B, we don't actually have anything, or I guess the second part here. We don't have anything yet. But from our angles, we can draw out what part 2 will look like. So we have, this one will be above this one, since this one is a lot closer to going straight east. And this one's a lot closer to going straight north because this is 32 degrees off of north and this is 12 degrees off of being east. So we have put our starting point here. And then this will be our 225 kilometers. And see, I put it so then it's about 12 degrees of where east would be. And then our other one for total displacement is 540 kilometers. So then this one's 540. So then this little line right here would have to be our second part. Make it a little darker so it's easier to see. Okay, and then remember this is 12 degrees from here, that line there, and then this one here is 32 there. Okay, so when we look at this, we can see based off of the triangles that we are going to have to do a vector component method. So how we will start this is we need to find the sides of each of these triangles to be able to find our second part. So we'll start that. So we can use sin 32 is equal to x over top of 540, because to find x, sin is equal to opposite over top of hypotenuse, so x will be our opposite, and then this will be equal to 286.2 kilometers, and then it's going east since it's going in this direction on the triangle. And then we can use cos to find the y. So we'll use the same equation, but instead we throw in cos because it's adjacent over top of hypotenuse. And this gives us 457.9 kilometers, and then this one is going north. And then for our next part, we can see that sin 12 is equal to y over top of 235. And this one's like this because, again, remember how the angles are a little bit different because we got, this one was going east at the beginning and this one was going north. So, sin 12, so sin is opposite over top of hypotenuse, so instead of it being x, it's y, because the angle's in a different spot than it is for this one up here. So this here equals to 46.8 kilometers, and since it's y and it's going up, we get north from it. Next we can do cos to solve for the x. Same equation again, but instead we use cos since it is adjacent over top of hypotenuse. And from this we get 220.1 kilometers, and this one is going east since it's going this way here. Okay, so now since we have all of our numbers, we can put these together to find the part B, which is here. So for x, let's start by doing x. We can take, so since this is the total and this is just the one part, normally if we were doing vector component method and we were solving for the total displacement, we would have to add the part 1 and the part 2 together. but since we are solving for the second part and we have the total, we will have to take the total and we will have to minus the first part of it to find the second part. Okay, so we will take 286.2 kilometers going east, and we will minus out the first part to find the second part, which is 220.1. And now this one minus this one is equal to 66.1 going east. So we have our first variable for the x component of our triangle for the second part. Now we can do y. So again, we have to take the variable from the total and we have to minus out the first part. So we will do that again. So we have 457 kilometers going north, and then we can minus the 468 or 46.8 kilometers north, and this gives us a total of 411.2 north. Now on our triangle, we can draw that out. Be 66.1 kilometers for the x component, and it's going east, remember that. And then we have 411.2 kilometers going north. And then we don't have this angle here, but we would like to know it. And then this here is our total displacement for the second part of the flight. So we can now solve for that. So we can do a squared plus b squared is equal to c squared. Plug in our values here. So 66.1 squared plus 411.2 squared is equal to, I'll square root them all at the same time. We'll plus these together and then square root it. And that'll give us a total of 416.5 kilometers. So now that we have our total displacement for the second part, we need to still figure out this angle. So to figure that out, we can take tan and we can plug in our values here. So we will take opposite, since we're doing tan, it'll be opposite over top of adjacent. So we would take 411.2 and divide that by 66.1. This will give us a total of 80.9 degrees. Now with our sig figs, we will have to change them. So this one we will have to change it to 2 sig figs, since there's 2 sig figs here, 2 sig figs here, 2 sig figs here, and this one's 3, so it'll be 2. So we can round that up to 420 kilometers. And then for angle, we have 80, and we'll have to round that up to 81. And then we can see from our diagram here that we are going east, and then we are going up north. So it will be east 81 degrees north.